LAN architecture. In this video, I'm going to talk about local area network or LAN architecture. You know that in previous videos, we have talked about many topics related to the LAN. We have learned about the Ethernet and different versions of the Ethernet, such as fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, and so on. Also, we have learned about the media, the layer 1 media that we have on the LAN, today's LAN. For example, we have learned about the twisted pair cables and also about the fiber optic. And also you have learned about the Ethernet frame. You know the content of the Ethernet frame, such as the source MAC, destination MAC address, type field, and also the SFD field, and also the preamble field, and also FCS field. After that, we have learned about the VLANs and trunks, about the broadcast domain, collision domain, and many other topics related to the LAN in the level of the CCNA class. And also let me to emphasize that you will learn more than this about the LAN in the higher course, such as the CCNP courses. But in this video, I am going to talk about the architecture, not about the configuration. What is the architecture? I am going to talk about different levels of, for example, network device, network switch, and the name of them, the responsibility of them, and some other topics related to the design. You know that in the enterprise courses, we have some special courses exactly for design, and you will learn more than this about the design in that courses. But here we are learning only some special and some maybe most important topics about the LAN. In the future, you will learn more than this about the LAN and also the design. First, let me to review the history of the today's LANs. You have learned about this history in the previous video, but here I'm going to review them because I want to give you more information about the LAN architecture. Look at the picture 1. In the picture 1, you can see one simple LAN. In this simple LAN, we have a shared media, okay? And also we have 4 computers, 1 server, 1 printer that connected to the network. This is a simple LAN, or maybe most simplest LAN that you have seen now. Here, as you can see, we don't use any switch. Because of that, all of these devices are working on one collision domain and also on one broadcast domain. This means that these devices need to enable CSMA-CD for preventing or reducing the numbers of the collision, as you have learned before about the CSMA-CD. After that, you know that because here all of these devices are maybe it's possible to experience collision with each other. All of them are working in one collision domain, and also the broadcast of these devices can reach to each other. All of them are working in one broadcast domain. How we can create this type of network? You know that this is the legacy network, and we don't create this type of network today, but maybe you heard before that in the old days we had some topology such as the bus topology. In the bus topology, okay, this is the bus topology, oldest topology of the network, okay, and today's we don't use the bus topology. In the bus topology, we have used the coaxial cable, okay, some type of coaxial cable, and also some special components such as the terminators at the both ends of one, for example, media. And after that, this is the terminator. The terminator actually is one, for example, resistor that should absorb the remaining electrical signal in the line. Okay, it is not important for now to learning about the bus topology because the bus topology is a legacy topology. Only I'm going to review some of the topics. Here we had one terminator. Here we had another terminator, and also we have a special type of connectors. We call them the T connector. With the T connector, okay, because T connector shape is like a T, we can or connect for example, the line to the PCs to the other devices. Actually, in the bus topology, we have used the T connector, and also one end of the T connector connected to the PC, and another types to another sides of the T connector connected to the line, like for example here, as you can see. Okay, and the PC and some other devices can use this T connector to connect the network. This is a simple technology topology that we have used before, but today's we don't use it. This is the same collision domain and broadcast domain. It is not important for us, but another type of the single collision domain and broadcast domain is using the hub. Let me to show you here in the packet tracer. I'm going to add one hub. This is the simple hub, and also let me to add, for example, for PC1, PC2, and PC3, and also if you want you can add one server. This is a server. If you connect this hub to the PCs, okay, we will have exactly this topology. Maybe you say that here we don't have any hub. Yes, this is logical diagram. In logical diagram, maybe we don't need to for example, use all of the transparent devices such as the hub. Because of that, this is a network with single collision domain and with single broadcast domain. You know that the hub floods all of the received traffic. Because of that, if the PC0 is sending traffic, let me to show you where the 192.168.1.1 is the IP address of this PC. And also this PC1 has IP address of 192, for example, 192.168.1.2. Look at here, when the traffic from PC0 is sending to the 192.168.1.2, we have for example connectivity, but in the simulation, you know that if we filter, for example, ICMP, we will see all of the frames should be flooded. Look at here, this is the ICMP echo request. This should be flooded. This means that now exactly at the same time, if the other system sending traffic, we will encounter with the collision. Okay, and also you know that here all of these systems are residing in one broadcast domain and also one collision domain. And this means that in the first days of the network, the network was not so efficient. Why? Because we had collisions, and also the broadcast domain can be extended to 1,000 computers or more than this, and this means that we didn't have any option, any tools to reduce the size of broadcast domain or increase the numbers of the broadcast domain. Because of that, this network is not efficient, you know it. Okay, after creating the switch, you know that in the for example picture 2, you can see that now we are using the switch can divide the network into the multiple collision domains. Here you can see that we are using switch. I have explained this before. With switch you can create multiple collision domain in each port, in all of the ports. Actually, in each port we have one collision domain. This is the collision domain 1 or CD1. This is the collision domain 2, okay, CD2. This means that between the ports of the switch we don't experience the collision, you know it. This is the collision domain 3, this is the collision domain 4, okay, and after that this is the collision domain 5, and finally we have collision domain 6. Actually, we can say that if a switch has 100 interface, okay, we have 100 collision domains. So easy. And you know that this is the benefits of the switch, one of the most important benefits of the switch. And also you know that the switch by default flood all of the broadcast frame to all of its interfaces except the incoming interface. For example, if PC1 sending broadcast, this broadcast should be flooded to the other interfaces. And you know that, as I mentioned before, as I explained before, this is not so suitable for large network. If you have, for example, 50 switch and maybe for example 500 or maybe a little less, a little more computers, all of these computers are receiving the broadcast, and this is not good. I have explained them before. Here we are reviewing only. Because of that, you know that all of the interface of the switch by default are working in one broadcast domain. Okay, look at here, this is our scenario. In this scenario we can replace the hub with one switch. Let me to show you the next step. This is the next step. Now the hub replaced with one switch. Again, we can use, for example, for 3 PCs and also one server. Let me to show you. Okay.